Welcome back, folks. So today we're going to take a look at just solving some more trig equations, but now we're just going to make them a little bit spicier. So we'll do this one and we'll do one more video after this one, but we're going to take a look at this one first. And this one's a little bit different than the simple ones we had been looking at the last two videos. So let me zoom in here for you. Okay, so we want to solve cosine squared theta plus 3 cosine theta equals 2. Wait. This one's a little weird. I could do something. I don't even know what I could do here. So we could do a little bit of rearranging, right? This is just any other equation. So one thing I would do is maybe move everything to one side, right? So I have this now. Whoopsies. That would be equal. Sorry, minus 2 would equal 0, and I'm having a little bit of trouble here. All right, hang on one second. Okay, so I was having a little bit of trouble with that problem. So I called my buddy, Mr. Fung. I know him from high school, and we actually went to college together. And he sent me this to actually solve the problem somehow. I actually don't know what's in here. So we'll do a little, I guess, surprise unboxing in this video. Okay, so there's no instructions in here, unfortunately, and there's nothing really on the side of the box. Ignore it, this is not really helpful at all. But yeah, there's no instructions in here and nothing on the side, so I suppose these are just supposed to help us somehow. So I guess I'll just put them on and just see what happens. I think these are big enough actually to go over my glasses, so that was nice of him to get me a pair that's big enough to go over my glasses. So I'll just put these on, just see what. Oh, wait, that actually make. Oh, I think I know what he's getting at now. Okay, so this is pretty cool. So what happens is that when I put these goggles on, the equation actually looks different. So, for example, right now we see cosine squared theta plus 3 cosine theta equals 2. Okay, but when I put the glasses on, so we're gonna do this, and when I put them, now we see this, where I don't know where the cosines went, but I think I see something like this, where it says x squared plus 3x equals 2. So this we can solve, right? So I know how to solve this. Let's put these on, and let's just solve this one. So this is a quadratic, and we know how to solve those. So I'll move the 2 over. I got x squared plus 3x minus 2 equals 0. And I'll get, well, I don't think this is factorable. This won't quite work out, I don't think. So I think we're left with using quadratic formula or completing the square. So let's do that. I'll get negative 3, x equals negative 3 plus or minus the square root b squared, so that'll be 9, minus 4 times ac, so 1 times negative 2, all over 2a, which in this case is just going to be 2. Okay, so I got negative 3 plus or minus the square root of, that'll be 9 plus 8, so that'll be 17 over 2. And that's not too bad. So hang on a second. Let me grab my calculator and I'll be right back. Right. Alrighty, so I just decided to pull out my calculator for this one. So I got x now. It could be two things. I have x equals 0.562, or x is equal to, or x is equal to negative 5.62. So, well, we know what x is, but we don't know what theta is, because we're not trying to solve for x. We're trying to solve, if I remember correctly, the original equation involves cosines and thetas. So let's take off the glasses and see if this helps us in any way. Okay, well, now that I've taken off the glasses, well, remember the equation that we just solved was the exact same thing, except instead of cosine theta, it was x. And so that one was just a quadratic, and so this really is just a quadratic that looks like, well, some weird confusing thing. But beyond that, it's really just a quadratic at heart, plus a little bit more here. So if x before, with the glasses on, was 0.562 or negative 3.562, well, that just means cosine theta could be either of those two values. So let's think about this. For what angle is cosine of the angle equal to this or that? This one, we should be able to rule out right away. Well, why is that? Well, remember that no matter what cosine is, we know it's at most 1 and at least -1. So this is actually already not a solution, not even going to happen. So we don't have to worry about that one. And now we just have to get back to this, which is something that we've done. We're just going to have to use our calculator here and get inverse cosine of this number, this ratio, 0.562, is equal to theta. I'm going to use my handy dandy calculator here. Well, actually, let's pull out our own Mr. Calculator on the computer so you can all see. Stand by. Alright, here's our calculator. So we're going to need to, oops, let's pull this over. So we're going to want to evaluate inverse cosine. So let's pull out our trig. Inverse cosine right here. Inverse cosine of, oh, sorry, we're going to want to be in radian mode. Inverse cosine of 0.62. Oh, wait, sorry. I almost never used the on my built-in calculator, so let me clear this. 0.562, and then evaluate the inverse cosine of that. And I'll get 0.973. Sorry, it's really tiny. How can I make this bigger? Does this do anything? Boom. Boom. Okay. 0.974. So theta is equal to 0.974. In which case, remember, let's think about this. Draw a picture to remind ourselves what angles this actually is. So 0.974, that's somewhere around here, right? Because 1 radian, again, is around 60 degrees. That's probably a little too steep. Pull it right here. So this angle, again, 0.974, that'll be right there. And remember, we want cosine is equal to 5.62. So that would mean an x-coordinate right here. The x-coordinate is equal to 0.562. But that could also happen on our unit circle. That's really messy. I apologize. That could also happen. Oops. Let's change the color here. That could also happen down here. Right? So right here, that could be x equals 0.562 as well. But what angle would that be? Well, that angle, it depends on how we want to phrase the angle. But this angle down here, theta 2, we'll call it, that would just be negative that angle, right? So that'd be negative 0.974. We didn't specify the domain, by the way, of our equation. So if we want to just phrase this for every possible angle, let's pretend that theta could be any real number. Then we're going to have to say, well, let's see, plus 2 pi n again, because every revolution thereafter will still work. And likewise on this angle down here, plus 2 pi n. Okay, so really, this is just another type of problem solving where really the solution is to just get yourself a pair of fancy schmancy goggles and just change the way that you look at the problem. Alrighty, I'll see you in the next video, folks.